Hello everyone, today we're going to be going over the August 2024 Algebra 2 Regents exam. In this video, we're going to be looking at part 4, which is made up of one question worth 6 points. A link to this test is in the description of the video if you want to follow along. That being said, we're just going to go over this one problem. It reads that Taylor wants to open an investment account with the $1,200 she received from her birthday. She has narrowed her choices down to two banks. America's Bank offers 6.4% annual interest compounded quarterly, and Barnyard Bank offers 6.35% annual interest compounded continuously. Write functions A of t and B of t to represent the value of her investment with America's Bank and Barnyard Bank as a function of time t in years. So all they want you to do in this type of problem is just write two equations. They want you to write the equation A of t and what it's equal to, and they want you to write the equation B of t and what it's equal to. Luckily, we know that A of t is going to represent her money when it's in America's Bank and when it's earning this amount of annual interest. And we know that B of t has to represent her money in Barnyard Banks earning this amount of interest compounded continuously. So for A of t, America's Bank, she's earning this interest rate, 6.4% compounded quarterly. So when something is compounded quarterly, you're going to have to use the compound interest formula, which reads something like this. A, which is the amount of interest that you're going to earn, is equal to P times 1 plus R over N. In this case, R is your interest rate, N is the amount of times it's being compounded. And this is all raised to the power of NT, where T is time, the amount of years, and N is, again, the amount of times it's being compounded. Right? So in this case, we know that it's being compounded quarterly. So if something is, think about what a quarter is. A quarter is 1/4 or 0.25. It's always going to represent 1/4. So if something is being compounded quarterly, it's happening 4 times for every one whole thing that occurs, right? If you're compounding something quarterly, that means that you split the year into 1, 2, 3, and 4 parts. So for something that's quarterly, your n is going to equal to 4, okay? In the problem, we know that she started off her account with $1,200. That's her initial. That's what P represents. So if we represent this as a function, all we need to do is just plug in the values that we already know. So A of t is going to equal to $1,200 times 1 plus our interest rate, which is going to be 0.064 divided by n, which is the amount of times it's being compounded, which we already said was 4, raised to the power of 4 times t, where t is the amount of years that pass. Okay, why did I put 0.064? Well, that's because 6.4% is equal to 0.064. You cannot put 6.4. That's a completely different value. Whenever you're plugging any numbers into these type of equations, you always want to convert your percent into a decimal. Okay, so that's the first one. The first formula answered correctly, but now we have to represent B of t. And the difference between A of t and B of t is that B, Barnyard Bank, their annual interest is compounded continuously. So when you have continual interest, your equation is going to look like A is equal to P e to the power of R and T, right? So in this case, instead of it being compounded quarterly, instead of earning a set interest every 4 times a year, 3 times a year, 2 times a year, this is going to earn interest every second, every millisecond. It's going to earn interest continuously. So it's continuously being compounded by the second. As I'm speaking right now, that account is going to earn money. It's going to earn, it's going to earn, it's going to earn. Okay, so it's pretty much compounded like an infinite amount of times, which is what this magic E is going to represent, right? This magical E, or this special number, kind of represents 1 plus R over N if N was being added like a million times, or an extremely large amount of times, because remember, N is how many times it's being compounded, right? So if it's continuously being compounded, it's going to be compounded infinitely many of times, right? Every second, every millisecond, every microsecond, so on and so forth. So that's the only difference between these two formulas, aside from the fact that R, your rate, is included in your power, which makes sense because, again, if it's being compounded an infinite amount of times, there's no need to raise it to that power, okay? So this E kind of covers that, if you guys were curious on what it meant. So in this case, A is equal to P times E to the power of R times T. So again, she invested the same amount of money initially, which is $1,200. We're going to multiply that by E raised to the power of 0.0635 times t, which is the amount of years that pass by. Why did I use 0.0635? Because again, that's 6.35% converted into a decimal. And it's also, you have to remember that the 2% or the two rates change between the two banks, right? So if you have that, then you're going to get full points on this test. If you really wanted to, you can simplify your answer to a of t. You can actually do 1 plus 0.064 divided by 4, and you can get that a of t is equal to 1200 times 1.016 to the power of 4t, if you choose to do that. Moving on to the second part of the problem, it says that Taylor would like to invest $1,200 into one bank for 10 years, making no additional deposits with no withdrawals. Which bank will Taylor earn the most money? So in this case, these two functions already tell you how much money she's going to earn based on how many years you leave it into the account. That's what your t's represent. So in this case, you're just looking at which one of these is going to earn more money if you let it sit for 10 years. So you're just plugging in 10 for both of these equations. So here you're finding a of 10 is equal to 1,200 times 1.016 raised to the power of 10. Okay, if you evaluate this, this is going to equal to 2,264 dollars. I was writing this wrong. $2,264. I have my calculator on my desk right now. 0.28. You just plug this into your calculator and you get that. So that's how much money she will earn using America's Bank. And finally, with the Barnyard Bank, b of 10, or the function b of t when you plug in 10 for the value t, is going to equal to 1,200 times e raised to the power of 0.0635 times 10. And if you plug that into your calculator, you're going to get 2,264.43, right? Or 43 cents. So which bank will Taylor earn the most money? Well, if you think about this, it has to be Barnyard Bank, right? So she will earn the most amount of money at Barnyard Bank. Okay, and my justification why? Because $2,264.43 is greater than $2,264.28. It's as easy as that. That's all you need for your justification, right? One is bigger than the other. Moving on to the last part of the problem, it says that Taylor chooses to invest her money in Barnyard Bank. Algebraically determine how long to the nearest tenth of a year it will take her initial investment to triple, assuming she makes no deposits or withdrawals. So again, her initial investment was $1,200 in this case. Okay, so if we want this to triple, we just multiply it by 3. That's equal to $3,600. Okay, so remember, we're going to look back to the original formula we wrote, and we're going to see that we're going to be using the red. So b of t is equal to 1,200 e to the power of that. Remember that b of t, or in this case our a, is equal to the amount of money that's going to be in the account after a certain amount of years, right? So we're trying to solve for not b of t, but actually t this time. We're seeing how many years need to pass in order for our b of t, or in order for the amount of money in our account to equal 3 times what it was initially. Initially, it was $1,200. So if we multiply that value by 3, we get $3,600. And we just need to write that $3,600 is equal to $1,200 times e to the power of 0.0635 times t. And now we're solving for t. So this is how much money our account was worth after we let it sit for an unknown amount of time, and now we have to solve for that unknown amount of time. So in this case, we're just going to solve for t algebraically. We're going to divide both sides by 1,200. This is going to equal to 3, and 3 is going to equal to e to the power of 0.0635t. Now, if you're stuck here, you have to remember your log and your natural log rules. In this case, because you're dealing with e, you're going not to use log, but you're going to use natural log. Natural log is a special function that we're going to only use for e. Okay? If this was, for example, 7, we would use log. But because it's e, we need to use the natural log because the natural log works on e. So whenever we do this, we just need to remember one very special rule. When we take the natural log of, let's say, a raised to the power of b, it gives us b times the natural log of a. Okay, so in this case, we can represent e as a and the thing it's being raised to as b. So we're going to have to take the natural log of both sides. Okay, and I'll write that down here actually because it seems easier there. So again, if you have a variable that's stuck as a power, the only way you can get it out of that power and kind of bring it down to where the rest of the numbers are is by using log or the natural log. Because we have e down here, we're going to use the natural log, okay? So we take the natural log not on one side, but on both sides, right? Because whatever you do to one side, you have to do to the other. So we have the natural log of 3 is equal to the natural log of e to the power of 0.0635 times t. Now we can't really rewrite ln of 3, but we can rewrite the natural log here. Remember, ln of a to the power of b is going to equal to b, which is what's in the power, which is 0.0635 times t, multiplied by the natural log of a, which in this case was e. Now, another important rule to know is that the natural log of e is equal to 1. So this is actually drops down into 0.0635 t times 1, which is the same thing as leaving it as itself. From here, it's really easy to solve. All you have to do is just divide both sides by 0.0635. If you plug that into your calculator, let me see right now, you should get 17.3 years as your answer. So it'll take 17.3 years for her money to triple on the account. If you want to check your answer, you can always plug this back into your original equation up here, and you should get somewhere around $3,600 as your answer. If you get 3,599.999, you can assume that you're right as well. So again, all you needed to know for this problem is just your natural log rules, and that the natural log of e is equal to 1. This is why we use the natural log instead of the log, because the natural log just simplifies it into 1. Super easy to work with. If you have any other questions about this specific problem, please let me know in the comments below. Other than that, that's how you earn full points on part 4 of the August 2024 Algebra 2